Hello. In this video I'm going to look at the fundamental trigonometric identities, and I call these the toolbox because these are the only identities that I use when I verify other identities. So in this video, I'll call it part one. I'm going to look at these, and then in a second video I'll look at the one that's so fundamental, sine squared plus cosine squared equal 1. All right. So I'm going to start here with cosecant theta. Show that is the same as 1 over sine theta. So I'm actually going to start on this side, 1 over sine theta. And then I'm going to use the definition of sine as y over r. And of course I'm going to simplify this, so I'm going to take the reciprocal and it'll become r over y, which we know by definition is cosecant theta. Okay? Now I'll let you do some of these on your own. So the next one I'm going to look at is this one here, tangent. So let me write it up here. Tangent of theta is equivalent to 1 over cotangent of theta, and that's equivalent to sine theta over cosine theta. Okay. So what I'll do first is work with this. So I'll say, okay, if we're working on tangent theta equals 1 over cotangent theta, I'm going to do very much what I did before. I'll just work with definitions. So 1 over cotangent theta would be the same thing as 1 over x over y. And now I would flip and multiply and get y over x, which we know is tangent theta. Okay. Now for the other one, to show that tangent theta is the same as sine theta over cosine theta, again, I'll just apply the definitions. Sine is y over r, cosine is x over r. But when I flip and multiply, I'm going to get y over r times r over x, right? And of course the r's cancel out, and I'll get y over x, which we know is tangent theta. Now technically I should be working down, that would be a lot better, but you won't be able to see everything. All right, so then let's look at these two. Sine of opposite theta is the same as negative sine theta. Okay, so let me write that down. Sine of the opposite of theta is the same as the negative of sine theta. Now here I want to go back to the definition of sine. We know sine of an angle is y over r, and of course that ratio stays the same regardless of what size circle. So if we use the unit circle where r equals 1, I'll be able to say that sine of theta is really the y coordinate. So now let me take, for example, here's a circle, and suppose theta itself, let me use a different color here. Suppose theta is here. I rotate this much, and this is theta. Okay. Now the y coordinate associated with that is going to be right here. This distance right here, that's the y coordinate. Now that's for theta, so if I look at this side where it's taking the sine of theta, so here's theta, and I take the negative of that, then my y coordinate will end up being here negative, so it'll actually be here negative y. So this here is really negative y. But if you look at it, then on this side, if I instead rotate negative theta, well, if positive theta was over here, the negative theta is going to be over here. So it's going to be the same triangle, right? So it's going to have the same y coordinate, but the y coordinate is what? It's negative. So these two quantities are actually the same, all right? And let's take a look at cosine negative theta. Oh, and by the way, you can prove for yourself that this is true, like maybe bring theta over here and then see what negative theta over here, and prove to yourself that this remains true regardless of what the rotation of theta is. So I'll let you do that. And here, the last one, cosine of opposite theta is equal to cosine theta. So let me write that up here. And again, I'm going to appeal to the definition here that cosine of theta is x over r, but on the unit circle, it's really cosine theta is just x, the x coordinate. And again, remember the ratios are all constant, so it doesn't matter which circle I'm working on. I'm just making it easy on ourselves here. So if I look at them, again, on a circle, and I say, okay, let's take a look at just theta. So here's, I rotate out theta, right? Here's theta. Well, the cosine of that angle is the x-coordinate. So it's this length right here. When I drop a perpendicular, it's this x-coordinate. It's this length right here. But notice that if I were to go negative theta, right, then I would be rotating this same amount, but in this direction. Right? And so notice that, of course, when I drop to the x-axis to create the reference triangle, notice that the x-coordinate is exactly the same. So it doesn't matter whether I rotate in a positive direction or negative direction, this x-coordinate is the same. So they're equal to each other. And again, if you were to rotate out here, right, then you'd have this x-coordinate. If you rotate out here, you'd have this x-coordinate. So it doesn't matter how far you rotate. This is an identity that's true for all theta. Okay? And that's why it's called an identity, because it's true for all inputs regardless. Great, thank you so much for listening.